Okay, let us now start writing the program. I have already written the menu function there. It's going to display the menu to the user for linked list operations. These are the 10 operations that we are going to write there in our program. The first one, as you can see, it's load from file. It's just going to read a file that contains some integer numbers, and it will read one number at a time. We'll create a node and put the number there in the node, and we'll append the node with the linked list. So if there are 10 numbers in the file, it will create 10 nodes and will ultimately create the linked list. Okay, so the second option is insert at head. That's going to ask for a number from the user, and it's going to put that in a dynamically allocated node, and ultimately the node will be added as the first node of the linked list. The third option is insert at tail. It's going to create a node and put a number there, and we'll add that node as the last node. That means at the end of the linked list. The fourth one is print list. That's in detail. That's going to print the content of each node, including the node's integer number and the content of the next field, along with the address of the node. We'll see how that works. The fifth one is the print list. Data only. That means it's going to print the integer numbers in each node. And sixth one is the find operation. That's going to search for a number in the linked list. It's going to be a sequential search starting from the very first node until we get the target or we reach to the end of the list. Seventh is the delete first. That means it's going to delete the first node of the linked list. We'll see how that works actually. Delete last is the operation that's going to delete the last node of the linked list. Now number 9 is delete a target node. It's going to search for the target node in the linked list, and then if that exists, it will delete that node. The reverse operation is going to reverse the whole linked list physically. That means if you call the reverse operation twice, the linked list is going to remain same. 11 is actually the quit, and that means it's going to quit the loop and the program will terminate. So these are the operations that we are going to implement. Now let me show you the function prototype declarations there. These are the prototype declarations of all the functions. The first one is the init list. Now you can see that each of these functions receives the linked list pointer. That means it's the address of the linked list object that we are going to declare in the main operation or a client function. So I'll show you that. So init list is going to receive the address of the linked list object. The linked list object contains the head, tail, and an integer to hold the node count. So it's going to initialize both the head and tail of the linked list object with null, because when we start our program, no node exists there. So the head and tail pointer must be initialized with null, and the node count has to be initialized with 0. We'll do that in the init list object. And you can see the other function declarations there. I will explain each of them when we implement them. So let us now first implement the init list. Before I go ahead and explain how we can write the init list, let me just show you that at line number 62 I have declared a linked list object. You see that list. It contains a head pointer, that's a node pointer, and a tail pointer. I have explained that in the earlier tutorial. And then I'm calling this init list function, and you can see that we are passing the address of the linked list object. List is the linked list object that is declared locally within main. So when you call the init list function, you need to pass the address to the init list function so that the init list can access this linked list object. So there in the init list, we have this list pointer. That's actually the linked list pointer. You can see that it will receive the address of the linked list object that we have declared in the main with the name list. So let us now go ahead and write the init list. Here we need to initialize both the head and tail pointer with null. So let's do that. lstptr arrow head. Since this is a pointer, we need to use the arrow operator in order to access the member. So that's going to be null \0, and then nstptr arrow preview. Tail. That is again null, and lstptr arrow node count. That's going to be 0. So that's done. So we are done with the initialization. So if you call this init list and pass the address of the linked list, then it's going to initialize the linked list object. All the elements of the linked list objects are now initialized. Okay, now what we are doing, we are calling the menu function there. It's going to print the menu. The rest of the main function is just quite similar with the implementation of stack and queue. We did this portion there as well. We have a while loop there, you can see that, and this while loop is going to iterate as long as you do not choose the quit option. Okay, that's option 11. So it will ask the option of the operation to the user, and whatever the user chooses to do, it will be taken in the choice variable there, and there is a switch case. It will compare the choice with case 1, case 2 up to case 11 that we will be writing in the subsequent tutorial. Okay, so let's now go ahead. In the next tutorial, I'm going to implement the create list and insert at head and insert at tail. Thank you.